Okay, well, in this lesson, we are doing like a bonus lesson on permutations and combinations. Now, it's a fairly awkward topic to get your head around, so for in case you need it, on this extra video, we'll just go through a few more examples of basically all the types of questions you're likely to see in a test, exam, whatever. So typically you've got like 4 main types of questions. I'm going to go through sort of each one at a time, sort of show you what you kind of expect to see. First, we're looking at picking items from a list with repetition. That's basically where you can pick the same item twice. So the common example is like a key code or a combination lock, where you can pick the same number more than once. So here I've got a door system of 4 numbers. I could have the code 99999. There's no reason I cannot repeat each number more than once. Want to know how many combinations there are? What we always do, we're going to think about it in terms of options. So basically, we've got 4 numbers to pick. So we can kind of think about it almost like Hangman, and think how many choices we have for each number. So for my first number, I should have 10 choices. I've got 1, 2, 3, 4, 5, 6, 7, 8, and 9, and 0, which is kind of my 10th choice. So I have 10 choices. And then for my second number, I've got the exact same 10 choices. Okay, typically, most questions you have 9 choices now, because we can't pick the same number twice. But in this case, we don't have that rule. We can pick, so we can start with 2 3s, we can start with 2 4s, whatever. And that keeps on going. That means for every single number you pick, because you have no restrictions, it just stays at 10. So 10 times 10 times 10 times 10 is going to be 10 to the power of 4, which is 1 with 4 zeros behind it. Or 10,000 combinations. Okay, and we're going to extend that idea. So here, this key code has 6 numbers to be entered. Let's add those down, 6 numbers, and we can enter the numbers 0 to 9 and the letters A to D. So let's count up how many options we've got. We've got 10 options here from 0 to 9, and then another 4 with A to D. So in total we've got 14 options. And again, just as before, there is no limit on which number we can pick again. So we can pick any number again twice. So for all these key entries, we've always got 14 choices. Okay, and then working that out, that is going to be 14 to the power of 6. It's going to be a huge number, so in this case, over 7.5 million. Okay, that was the first type of question. Next, what we're going to see more often is where you're picking different items from a list. So in a race of 20 people, how many different ways can people finish first, second, third, and fourth? So, in a race, you've got 20 people running, and any of those 20 could finish first. Okay, that's my first number, and I want 4 of them. That person is now finished. Okay, so in the field, there's only 19 people left, and again, any of those 19 remaining people could finish second, and we keep on going. Now there's only 18 people left, and now only 17 people left. So for these questions, you always have to take one off, because the same person can't finish first or second, or you can't pick the same item twice in a row. Then you just type it into your calculator, work it all out. In this case, it's 116,000 odd. Okay, this was the easiest type of question. In this question, what I say is that the order mattered. So what I mean is, if we switched around my first and my second person, I would have a different race result. Okay, that means the order matters. It matters who comes first, second, third, or fourth. If we show you kind of the exact same question, let's show the exact same question again, where instead I just want people to finish in the top 4. So here I wouldn't care who came first, second, third, or fourth. In this question, the order would not matter, which makes it a bit harder. But we'll see that in a second. Okay, so for this question, we want to pick a head boy and a deputy head boy from a group of 42. So we've got 2 people to pick. For the head boy, we have 42 people to pick from. That person is now picked. We cannot pick him again, which means there's 41 choices left. Okay, type in a calculator, and that will work it out for you. Now, as I said earlier, we're looking at this question now. In a race of 20 people, how many different ways can people finish in the top 4? So we don't care who comes first, second, third, or fourth. As long as they finish the top 4, that's all we really care about. So it's going to be less choices, obviously, because we've got basically more freedom to mix people about. This method starts the exact same way. we're going to basically pretend we're working as normal. So we do 20 times 19 all the way down to 17 because there are 4 people. So we want 4 numbers here. And then we're going to have to divide it by something. And we're basically going to divide it by the number of ways we can mix around those top 4 people. So what I mean is, let's just say we had 4 people. I'll just call them A, B, C, and D. If I mix the order around, so if instead I had C, A, D, B, that's still the same race result. It's still the same people in the top 4, so I don't want to count it as a separate race result. So I'm going to have to divide by how many ways we can organise these 3 people amongst themselves. Sorry, these 4 people amongst themselves. This works out as being quite a lot. You could totally list them all out, but that'll take a while. But we're going to do the same idea. We can just think how many choices we have. For the first person, it could be anyone A, B, C, or D. So we have 4 choices. For the second person, I've got 3 options left, then 2 options, then 1 option left. For maths, we have a symbol for this. This is called 4 factorial. Okay? And what we're going to do, because that's the amount of ways I could arrange any group of 4 people amongst themselves, we have to divide by this number. Because basically, for each race result I've worked out so far by doing this, there's going to be another 23 exact copies of that, just for the top 4 in a different order. Okay? Hope that made sense. So the key difference here was that the order didn't matter. We didn't care who came first, second, third, or fourth, so we had to divide. And pretty much 9 times out of 10, you always divide by the number of people factorial. So if there's only 3 people, we have 3 numbers here, and then we'd only divide by 3 factorial. Okay? Let's see another example. So back to the head boys question. In this question, we're picking 2 head boys from a group of 42. So they're the exact same role, so we don't care which head boy we pick first. Okay? So for our first head boy, we've got 42 choices, then we've got 41 choices. And again, because the order does not matter, we don't care which head boy we pick first, we have to divide. And because there's 2 people, we divide by 2 factorial. Again, type in your calculator, that'll work it out. And if your calculator doesn't have a factorial button, you can just do 2 times 1. So remember, like 10 factorial will be 10 times 9 times 8 times 7 times 6, all the way down to times 1. Okay, just 2 types of questions left. We have like picking 3 items from 3 lists, which is basically like a restaurant menu option, or like picking fancy things for cars, that kind of stuff. So here, a restaurant has 4 starters, 6 main courses, and 3 desserts. We want to know how many meal combinations there are if we want a 3-course meal. So we've got a starter, we've got our mains, and we've got a dessert. So for the starter, I've got 4 choices. For the main course, I've got 6 choices. And for the dessert, I've got 3 choices. Here, just for a quick aside, we do not need to divide because the order does matter. Like I can't mix a starter and a main course. They're different meals. They can't be mixed around, which means the order does matter, so we don't need to divide. That is all we need to type in a calculator to get the right answer. Same idea, a choir is 7 men and 14 women. We want a man or woman to sing the finale. So you would just do 7 times 14. How many men times how many women, because how many choices you've got. This leads us nicely to compound questions, where you're basically picking multiple people from different lists. So let's go back to my choir question first. We know if picking 1 man and 1 woman, we would have 7 times 14 options, okay, or 98. Let's go to the same question, let's change it slightly. Now we've got 7 men, 4 women still, but now we want to pick a man and 2 women to sing the finale. Okay? So we're going to basically work out the men and work out the women separately. Or should be 2 separate questions. And then we're going to times them together. So same way I did 7 times 14, I'll do number of options to get the men times number of options to get the women. So I'm only picking 1 man, so there's only 7 choices. So that one's fairly straightforward. I now want to pick 2 women from a total of 14. And again, here the order does not matter. I don't care which woman I pick first, and that means I have to divide. So for the women, I've got 14 choices for the first one, 13 choices for the next one, and because the order does not matter, because I don't care who I pick first, I then have to divide that by 2 factorial. Okay, and that's it. I'll go quickly for the last example, which was back on restaurant menus. So you do the same thing here. So restaurant still has 4 starters, 6 mains and 3 desserts. In this question, we only want a 2-course meal. We either want a starter and a main, or a main and a dessert. Okay, this one is slightly different. Here, because they're completely disjointed, because we're picking either or, we're going to add our answers together. From the last question we looked at, we're picking men and a woman. Basically, when we see the and, it means times things together. Here, it was, because it was an or, we're going to add together our answers. So we're going to do starter and a main. I'm going to do main and a dessert separately, and then we're going to add them together. So starter and a main. Choices for the starter is 4. Choices for the main course is 6. Then we do main and a dessert. 6 choices for the main course and 3 choices for the dessert. And again, because it's an or, we then work these both out and then add them all together. Okay, and that will turn out at being 42, I think. Okay, that's it. I have written some questions to try. So give them a go. And I'll just quickly remind myself, one more question to go through that you occasionally see, just really quickly. So here we've got 4 starters, 6 main courses. Now there's X desserts. We don't know how many desserts they are, but we do know there are a total of 144 options for a 3-course meal. So we do it the same way. We've got starters times mains times desserts. That's going to be 4 times 6 times X. And now we know it equals 144. So basically, we've formed an equation that we need to solve in order to work out X. Way to do it, we have a bunch of stuff being times by X. The opposite of timesing by X is dividing. So all the stuff I want to get rid of, the 4 and the 6, I just divide by it. Type it into your calculator, and that'll work out X, which should always be a whole number. If you get a decimal or a fraction, something's gone wrong there. Okay, that's it. You have the sheet in the video description. Good luck, and I hope that helped.